Okay, my physics friends, just a little bit of information about vertical motion to help you with problem solving, because sometimes they can be a little tricky. So remember, we know that when an object is thrown up into the air, the velocity time graph of that object should look something like this, where the slope of this line is equal to negative 9.8 meters per second squared, as it's the acceleration. We also know that at this point, when it crosses the time axis, it goes from a positive velocity to a negative velocity, and so that indicates a change in direction. So if we keep that in mind, if I'm looking at a kinematics problem, and let's just say it's a ball that gets thrown up into the air with an initial velocity of 2 meters per second. If I sketch the path that this ball is going to take, well, according to my velocity time graph, it's going to slow down because the velocity is going towards zero. And at the peak of its height, it's going to turn around, and then it's going to speed up, but in the negative direction. So at this point, I've got a positive velocity over here, and over here I have a negative velocity. And on both sides, my acceleration is equal to negative 9.8. At the peak height here at the very top, that relates to this point when the object is changing direction, when the object goes from positive velocity to negative velocity. And well, what is the speed at that point? Well, it's zero. So at the peak, velocity is equal to 0 meters per second. It must in order to turn around. A couple other things. Because the acceleration of gravity is constant, that means that the time it takes to rise to the peak is the same as the time it takes to fall back down to the same level. So the total time, or the time to the peak, is 1/2 the total time. This is only true if it's a symmetrical path. If the way up and the way down, they cover the same distance. If, for example, your problem looks something like this, and the ball is thrown straight up from a leveled height, let's say that's 10 meters, and it goes up, and it falls all the way back down, this path is not symmetrical. The starting height is up at 10 meters, and we're ending at 0. It is true that at the peak, the velocity in the y direction is still 0 meters per second because it has to turn around. But the time up to the peak is not equal the time that it takes to fall down, because on the way down it falls through more distance. So the actual speed at the end here will be greater than the speed that it leaves the initial spot with. Okay. So using this piece of information, this idea that at the peak the velocity is 0, we can use that to manipulate the situation in order to solve what we'd like. And it comes in really handy for lots of problems.